Our last learning target is looking at learning target number 11, focusing on our third and final type of boundary, transform. So we already know a little bit about the motion of transform since we are differentiating it from both convergent together and divergent apart. And you've got a little bit of details happening here too, so you can be looking at both at the same time. But we can see on our picture here, the main motion of these transform boundaries is side by side, or that they're sliding past each other. Okay, oftentimes it's just like this one to the right and one to the left, where they're just moving horizontally past each other. There's no vertical motion here. So notice when we look at our features, there's no subduction, no plate going underneath the other one, like we see in convergent, right? And we see kind of a pretty straightforward view. We don't get a lot of extra details. Our only features here are earthquakes and something called faults. So when we're thinking about our data up top, we know to get a volcano, we have to see some sort of magma. And that's not happening either underneath the crust or on the surface. So volcanoes are not happening here, which means I have no location for them to occur at. It's just a straight up no volcanic activity. There's no magma happening here. We don't associate transform with a spot on the convection current. It's basically filling in the blanks in between the divergent and the convergent zones. As far as earthquakes go, we definitely still have those because the plates are moving. They're sliding past each other. In our particular picture, we are looking at two pieces of continental crust, but this can really occur anywhere on Earth. Earthquakes, just like before, are going to be represented with an X and are created by motion of those plates. So the most movement we see when these plates interact is right on the boundary line. And those plates are being slid past each other and essentially bumping up against each other, causing friction and additional cracking to the Earth's surface. That's what this fault is looking at. So a fault is a crack on the Earth's surface. We can label the boundary line as that fault or crack in the Earth's surface. So we do have earthquakes happening. They're occurring right on the boundary and right on the surface. So we're seeing them on and shallow in nature. So when we think about motion of the boundary, we're simply describing that these are sliding past each other. Or side by side. Creating no volcanoes, but shallow earthquakes, because again, the plates are moving. So in your picture, we're thinking about arrows showing transform motion, just like in our other photo. Fault is this crack right here. And our last one, earthquakes, again, just like our other image, happening right on the boundary, location on the boundary, and depth is just shallow. So overall, this transform is a really low-key boundary compared to the other ones. Again, you got a little description paragraph here to complete by filling in your keywords.